and some demo, explain how it works and how you can use it, and even customize it for your own project. And at any point in time, if you have a question, you can type it in the Q&A chat, and my team of developers, Kevin, Diwei, and Sydney, will either reply you in the chat right away, or they will leave the question to be answered live in the Q&A session, which should start in about half an hour's time. And I think we should be able to wrap up this whole session before 8:45 or 8:50. So let's begin with why we built this. So my team has worked on many CV projects for industry. And what we found is that while the types of CV problems are very varied, many of these projects share repeated code, such as reading from a video or an image. And in some projects, even pre-trained CV models like object detection or human pose estimation can be reused. And we simply got tired of rewriting CV pipelines. So we decided to build this PeekingDuck framework to cut down development time for our future projects. So let's begin proper by going to the GitHub repository for PeekingDuck. And I think Sydney has shared the links with you guys already, but it's quite easy. You just need to Google GitHub PeekingDuck. And yeah, that should be the first one under AI Makerspace. And I guess the first question is, why do we call it PeekingDuck, right? So with a single E, it sounds like a restaurant dish. So we think that the name is easy for people to remember, but there's also a deeper meaning behind this. And why we call it PeekingDuck is because the first word Peking is because we are dealing with computer vision. And the second word duck is because it comes from duck typing. And because we are using Python, it's a dynamically typed language. And yeah, this is our logo. We kind of think that it's pretty cute, so we like it. And right now we have tested PeekingDuck on 3 Python versions, Python 3.6, 3.7, and 3.8. And we have also run it on all 3 major operating systems, Linux, Mac OS, and Windows 10. And most importantly, PeekingDuck is under the open source and permissive Apache 2.0 license. And that basically means that you can download it, install it, and you can do whatever you want with it. And without further much ado, let's go straight into the first demonstration. So you can see right here that the first step, you have to install PeekingDuck just by pip installing PeekingDuck. And I think those of you who are familiar with Conda or Python environments is encouraged to create one before you install. And I have already installed it, so I'll skip that step and I'll move to the next step, which is basically to create a project folder and to initialize a PeekingDuck project. So I'm going to, right now I'm at my desktop, I'm going to make a directory called demo. And I will go into that directory and run this command called PeekingDuck init. Right, so what this does is it actually initializes a PeekingDuck project. And you can see that if I go into this demo folder which was created, two things were created. First of all, is this run_config.yaml file. And the second is an empty source folder. So I will talk a bit more about these two later on. And we can just proceed with the rest of the demo, which basically is, okay, the next step is just basically to run PeekingDuck. So the command will be PeekingDuck run. And let's wait for a while for the model to load. So if you're doing this PeekingDuck run for the first time, it may take a while because it needs to download the model weights. But I've done it before, so you can see that it's quite fast. And yep, what you're seeing right now is the object detection task, where the CV model actually detects me as a human object, and it predicts my location, and it can draw the rectangle around me. And as I move around, it can kind of track me as well. And in CV terminology, this yellow rectangular box around me is called the bounding box. All right, so let's see what else we can do. And yeah, so basically, right, within just a few steps, once you install PeekingDuck, you can actually get a demo running right away. So for the next part of this webinar, I would like to explain how PeekingDuck works, because I think you need to have a good understanding of our underlying concepts before you can take it further. So the first thing that I want to talk about are nodes, which are the basic building blocks of PeekingDuck. And PeekingDuck has 5 different types of nodes, which are shown in this diagram over here. The first 2 types are the input and the output nodes. So the input nodes deals with taking in various types of inputs like videos from a webcam like just now, or maybe even a saved video. And the output nodes is responsible for showing it on the screen or saving out the video. There's also the model type of node, which is basically a compilation of the different CV models that we have. There's also the draw node, which is responsible for drawing results, such as the bounding box. And last of all, there's the dabble type of node, which I will talk about more later on. So yeah, those are nodes. And the next thing you need to learn is that we combine nodes into this thing called a pipeline. So remember just now in the demonstration, and maybe I'll just keep it running on the side over here. So you can see that this demonstration uses 4 nodes, and they all are combined into this pipeline. So let's look at the first one. The first node is the input.live node, which is basically responsible for reading from the webcam of my MacBook, and it extracts the frame by frame into this property called IMG, and it passes it into this thing called the data pool. And it basically goes to the next node in the pipeline, which is the model.yolo node. So this is the object detector, the CV model, and that takes in an image and it does a prediction and produces a bounding box or B box as we write here. And in the next phase in the pipeline, there will be the draw.bbox node, which basically takes in an image, B box, and then it basically draws the bounding box, which is the yellow thing around me on it. And last of all, the last node in this pipeline is the output.screen node that basically is responsible for showing this window on my screen, as you can see. And this basically shows how, in a simple demo, all the different nodes come together to form a pipeline. So I was talking about dabble nodes just now, right? So in PeekingDuck pipelines, usually it's the CV model that does the heavy lifting. And the dabble node basically usually just takes the results from the model and does a little something more with it. So we say that, dabble nodes are methods that dabble with model predictions to produce useful results. And there's another reason why we call it dabble, and that really just is to suit our theme of ducks, because you can see from this picture, maybe this is our picture. This is actually a picture of ducks that are dabbling. And when they are dabbling, what they are doing is they are poking their beaks under water to look for food. And just nice, it seems to suit our theme. So we decided to call this category dabble nodes. Okay, so now that you know about nodes and pipelines, let's move on to the next section. Additional features for PeekingDuck. So what we are looking at right now, right, is actually the main README documentation in GitHub, but most of our documentation is actually at the Read the Docs site. So let me open that up. And yeah, so this is our Read the Docs website where all the documentation is contained. So just a quick overview, we have an introduction section over here. And we also have a getting started section, which I have talked about briefly in the first part, and I will continue to talk about some of these additional features. And there's also a section on the different CV models that we have, the different use cases that we offer, and last of all, this section on API documentation, which we'll go through later on. So let's go back to what we did just now. So we installed PeekingDuck, and then we basically run this command called PeekingDuck init, which, as a recap, created this YAML file and this source folder in your directory. So what I'm going to do now is to open up this run_config.yaml file, and you can see that actually this contains all the nodes that were run in the demo just now, input.live, model.yolo, and these were the nodes that I was talking about in the pipeline example. So what I will do now is demonstrate to you how you can change these nodes. So instead of YOLO, I'm going to use posenet, which is a human pose estimation model. And instead of drawing a V box, I'm going to draw poses. Save the file. Let me just clear my terminal and run PeekingDuck again. Okay, so now it looks different, right? So what's happening is this is no longer object detection. This is a human pose estimation. So you can see that the model can get my eyes, my nose, my ears, my shoulders, my wrists, my elbows, even my hips. I can't show you my legs, but basically the task of this is to predict all 17 key points of a person. And let me just quit this. And the point of this demo was just to show you how easy it is to be PeekingDuck, because to change from a completely different task from object detection to human pose estimation, all I needed to do was to change two words, posenet and poses. Yeah, and I think it really demonstrates how flexible PeekingDuck is. Next, I'm going to show you how you can deal with saved videos, because just now both demos were using videos from my webcam directly, but now I want to work with saved videos. So the video I have in mind is this one. It's a 5-second clip of two dogs, ducks walking. And what I want to do is to use object detection to detect both ducks and draw bounding boxes around them and save the resulting video in an MP4 file. And in order to do that, we cannot use these nodes anymore. So this is when I think it's a good time to walk you through our API documentation. So let's look at the input type of nodes first. So these are the two input categories that we have. Live, which is for reading a live feed from a webcam, and recorded, which says you read a video or image from a directory. And this is the node that we need to use. So let's go into it and find out a bit more. So you can see that actually for every single node that we create, this API documentation shows the different types of inputs. In this case, it doesn't need any input, and the different types of outputs. And you should be familiar with this IMG. Basically, this is the output image that it produces frame by frame, and also the different configurations for the node. And in this case, I think we can stick with the default configurations. The only thing that we need to change is this input directory where I want to read the video from. So let's go ahead and do that. So no longer input.live, it will be input.recorded. And I will change the input directory to be reading from my desktop. And I think I created a folder called input over there. Okay, so that settles the first node. The second node, we are going to switch back to object detection again. So I will use YOLO. And this time round, we need to make another modification. So let's look at model nodes. And okay, we have a few different models, but the one I want to show you guys is YOLO. Okay, so says over here, the YOLO node is capable of detecting objects from 80 categories. So just now when I was doing the first demo, it was detecting me because I was a human category. But what I want to do now is to detect ducks, right? So I should look for whether ducks is within one of these 80 categories. So it says here that you can find it over here. So I'm just going to open this up. And okay, so YOLO class ID, this is what I should be looking for. And we don't have a duck class, unfortunately, but there's one called a bird, which is ID 14, which I think is good enough. So let's go back to this one and look at what is the name of that configuration, which would be detect underscore IDs. So you change it, you change the variable called detect underscore IDs. So let's go back to this and say that detect underscore IDs is going to be ID 14, which is of a bird. And we are not drawing poses, we are drawing the bounding box. And last of all, I said that I want to save out the video, right? So that would be an output node. And let's look at what we have. We have a output screen, which you guys saw just now. And we also have an output media writer, which is the node that we want to use because this writes the output video to a file. Okay, is there anything I need to change? I think the only thing I need to change is the output directory, where to save the file. So let's go back to the configuration file and I'll change it to output.mediawriter, and output directory would be my desktop again, but this time I will save it to output folder. Okay, and I think one last thing I also want to mention, and that's very important, is that if I want to change the configuration or the setting of a node, I do need to put this colon right after the node name. So you see that I put the colon after recorded, after YOLO, and after media writer. But for draw.bbox, I'm not changing any of its settings, so I'm just going to leave it there without a colon. Okay, and what else do I need to do? Okay, I need to move this ducks video into the input folder. Okay, and if I did not type anything wrongly, it should be able to run. Okay, so this time it's processing a video, so you can see that it actually shows the status of the video that's been processed. So when it reaches 90%, it should be done. Okay, it's done. Let's take a look at the results. And I saved it to my output folder, right? So let's take a look. Yeah, so it looks like the model really does detect these two ducks, and it manages to draw the bounding box around them. Yeah, so this works. Let's see what else. Oh, one other fun thing we can try is to give me a second. Let's try doing this. Right, so this is the real Peking duck with a single E. And yeah, let's just try and see whether our model can detect this as a duck. So again, I will just move this into the input folder. Do I need to change anything? No, because everything is the same. So I'll just clear the terminal again and run it. Okay, and this time it's done very fast because this is just one image, right? So it's just one frame. So let's go back to the output folder and look at the resulting image. And no, it doesn't detect it. I guess it's not surprising, but a roast duck is not the same as a live duck in the eyes of our AI model. Okay, so this basically sums up how you can change the nodes and the node settings. I think one other important thing to note is what happens if you do something like this. So instead of draw.bbox, I'll change it to draw.poses. Do you think this will work based on what I went through just now? Let's try it out. Okay, so looks like there's an error. And what it says is that the nodes in the pipeline do not form a proper channel. Reason for this is this draw.poses nodes, it actually requires certain types of inputs, like key points and key point scores. Remember, I was using draw.poses for the human pose estimation, where it was able to detect my eyes and ears and nose and all this. And all those are called key points. So if there is no model that is producing that, and in this case there isn't, it would basically throw an error because it doesn't have the required inputs. So this check is done right at the beginning. So sometimes if you're using PeekingDuck and then you get these kind of errors, you might want to just look through the nodes that you used and look through the API documentation and make sure that the inputs and outputs are all correct. Yeah. Okay, so I think this pretty much gives you a good understanding of how to use our API documentation. Next, I want to talk about how you can use extended features of PeekingDuck. And the first one would be how you can actually build custom nodes to run. So you may very well need to do that because there may be certain scenarios where, for example, right, what I wrote here is that you might want to take a snapshot of a video and post it to your API endpoint. Or another scenario, which might be quite common, is that you have a custom data set and you train your model on that. So obviously you can't use the models that we have, right? And in this case, you might still want to use PeekingDuck's input, draw, and output type of nodes. So that's not a problem because we have designed PeekingDuck to be very flexible. You can actually create your own custom nodes and use them with ours. And this guide actually shows you how you can do that. I will not go into the details for the lack of time, but at a very high level, what you need to do is to create a configuration file for your node that specifies what are the inputs and the outputs that are going into your node and any special settings for your node. And you also need to create a Python script for your node that basically shows what it does. And last of all, when you're done with that, in the run config.yaml file where I change all the node to be used, right? You have to add your new custom node into this. And that is basically how you can do that. Another feature that you might want to try is PeekingDuck's Python API. So all the demos that I showed just now, right, basically were from the command line where I ran this single line called PeekingDuck run. But sometimes we understand that you already have a project that has a code base already, but you want to use some of PeekingDuck's nodes. So what you can actually do is you can import PeekingDuck into your Python script, for example, like this. And you can basically do this to any one of our nodes, and you can extract whatever useful information you want from our nodes. And in fact, you can even use it on a Jupyter notebook or a Google Colab notebook. And we do have an example here on Google Colab where you can try it out. And basically, it might be quite useful for you to figure out how certain nodes in PeekingDuck work by going through this Colab. Okay, and another pretty interesting thing that we have is what we call use cases. Let me show you an overview. So these are the 4 use cases that we have. Okay, so we built PeekingDuck partly because we are interested to use computer vision to solve real-world problems. And this is why we created these things called use cases, which are basically a combination of nodes to tackle a single problem. So let's maybe look at this one, social distancing. Yeah, so this one basically, it was something that we created because of COVID, and it helps to identify if people are standing too close together. And I can demo this right away by copying this nodes over here. And yeah, just to note, you can see that the amount of nodes used for social distancing is a lot more. We have certain nodes like Debo, which basically, this one creates 3D location from 2D key points, and this one basically checks if 2 objects are too close together. And yeah, let me just save this and I'll run it. Oops. PeekingDuck run. Okay. Okay, so the demo is running now, but because it's social distancing, I need 2 people. So I need my fiance to guest star for a while. Okay, so let's do this. So you can see that right now we are too close, but if we go further apart, yeah, that doesn't happen anymore. So this is how you can use it. Okay, so other than social distancing, we also have other use cases like this group size checking, which is a similar idea where you kind of try to get the distance between people. And for this one, right, you can actually set how many people are allowed to be in a group. So in this case, the setting is 2. So once Sydney appears, it's 3 people, and then it says that it's a large group. So I mean, the government regulations have been changing from 8 to 5 to 2. So we have this setting where you can just change it, and so it's very flexible and accommodate different conditions. We also have this object counting use case, where you can see that there's a counter at the bottom, and it just changes depending on how many objects have appeared. And when I say objects, I don't just mean humans, but also any of the 80 classes of object detectors, like cars, animals, stuff like that. And the final one that we have is zone counting. Right, so this one is pretty fun. You can see that it's actually just a more advanced version of object counting, but in this case, the difference is that we actually separate the screen into 2 zones, and you can see that as T-Wei moves his baby from left to right, the number of humans detected in each zone changes. So this is just one simple example, but this can be extended to many cases. Like for example, you don't have to draw straight lines, you can draw some polygons or some rectangles, some triangles, and for example, you can draw a section around a shopping center shop and see how many people enter that shop. And that's pretty useful for retail analytics. And you can also use this to, for example, count the number of people in SBS bus stop, for example, and to kind of get a sense of how many people are waiting for buses. Yep. So let's see. Yeah, so these are basically the 4 different types of use cases that we have. And we will be adding more nodes and use cases over time. And finally, I'll go back to the final part of my presentation. Just to wrap up, I just want to say that my team at AI Singapore, we are committed to continue to maintain PeekingDuck, to continue to keep it open source and improve it over the years. And as you have seen, right, one of the main strengths of PeekingDuck is the modular node-based system. And with this, PeekingDuck is actually very scalable, and we are able to add more nodes and better nodes over time. So stay tuned for our latest developments. And I think, in fact, we are likely to do another round of release of new nodes and use cases, probably by September this year. And also, as some of you who are CV enthusiasts, you might know that there are still many developments in the field of CV, most recently of vision transformers and MLP mixers, which are both not using the typical convolutional neural network architecture. We are constantly surveying the CV scene, and we will add new models when the time is right. And meanwhile, we encourage you to install and try PeekingDuck and start our repository over here. And if you like it, also recommend it to your friends and your colleagues as well. And you are also welcome to join our discussions on PeekingDuck, either in our GitHub discussion board or the PeekingDuck Discord server. The links are over here in our readme. And I think last of all, to conclude, what we have found is that my team has benefited from using PeekingDuck in our industry projects. For example, recently we had a human pose estimation project with Genesis Gym to provide feedback for exercises such as bicep curls. And we found that actually using PeekingDuck really shortened our development time. And we are open sourcing PeekingDuck so that you, the computer vision community, are able to benefit as well. So thank you again for coming, and let's proceed to the Q&A section of this webinar. Okay, let's see. Sydney, you want to answer Kenneth's question?
Yeah, sure, happy to. So, Kenneth's question is really what are some examples of real life deployed projects that utilizes Peking Duck, and what are key challenges faced by us, in the process of integrating into business. So Peking Duck was actually officially launched version 1.0 in August, and I think since then we already have deployed it in one of the projects, right? So the project, as earlier mentioned, is a partnership with Genesis Gym, in which they actually have a mobile app where they try to be a one-stop, fitness pal for you, and they recommend you a set of exercises. And our job in this role is really just to take a video of you and give you feedback, right, of you're doing your bicep curls, for example. I would, like as Liping mentioned, it really significantly cut down most of our development time, because we don't really have to think about what format is our video is going to come in, after we do our AI models, what are we going to do with it, right? And where can we send this APIs information, the results of the models, right, to right? Because we just primarily focus on doing things that are not CV, right? This has really helped us simplify a lot of our CV workloads, and it's very simple. If I have to comment about the challenges, I guess Peking Duck is still, still a very, fledgling duckling, right? And there are a lot of times where, we want to encourage, we don't have to stay on the art models because the CV models are advancing very fast. And more often than not, we have to develop new nodes during the development phase, right? And I won't say that Peking Duck is mature enough to cover all your use cases, but it's a start, right? And definitely one day, hopefully, we get to cover all your use cases, and we don't have to develop any nodes anymore. But that's a stretch, a long-term goal for us.
Okay, thanks for that, Sydney. We have a few other questions coming in that maybe I can just try to answer. So first of all, Daniel, thanks for pointing that out, and I'll maybe just show everyone. So we have a few models right now, and we have two for human pose estimation, posenet and HRNet, and we have two for object detection, which is YOLO for an efficient depth. But amongst these four models, we actually have different subtypes. And this section in the reader docs under CV model that benchmarks, we actually show two useful benchmarks that you might want to consider before using our models. The first is we show the inference speed on different types of hardware. Like we compare it with my MacBook Pro and NVIDIA A100 GPU. And you can see that we actually have shown the different frames per second or FPS results on these different hardware. The other thing that we also show for benchmarks is the model accuracy. So we show the mean average precision over different, I think we are using the MS COCO validation 207 dataset. Yeah, so you can check out this section to find out more about our models. Thanks for bringing that up, Daniel. Okay, so Elson asks, what are some of the features that will be added in? I think we're still discussing, but you can see right now that we have a few models here, but there's definitely a lot more that can come. And also, we only have 4 use cases, but we probably will release a few more by the end of the year. I know that's kind of not answering your question, but yeah, just stay tuned to our LinkedIn page and our channel, and you'll find out by the end of the year. Let's see. Why PeekingDuck.jpg cannot be detected? Okay, so what is that PeekingDuck.jpg? That's basically this picture, right? So why was this not detected as a duck? Well, the reason for that is because the object detector that we were using is trained on a fixed set of 80 classes. So let's maybe go into that for more detail. So I showed you this page already, but basically just to give you a sense of what are the 80 classes. So one of the classes is person. It can also detect things like car, boat, traffic light, and then we talked about bird, right? And then even cat, cow, a few other things like that, backpack and stuff like that. So the reason why it wasn't able to detect this is because I guess it just doesn't look like a duck. I mean, we know what a rose duck is, but it just looks very different from a real walking, quacking duck. Yep. yeah, so someone also asked about casual. Yeah, so we actually looked at, as Sydney said, we actually looked at casual initially, but we found that casual is more focused on training pipelines, whereas you can see that Peking Duck, we are more focused on the inference part of it. And there was some aspects of casual that made it a bit more inflexible to use for inference. And after spending a few weeks looking at it, we decided that it's better off for us to create our own framework, which is why we have Peking Duck today. That's a very good question. Thanks. Okay asks, can we add classes for object detection? Most likely, if you want to, let's say, like, if you really want to train a model to detect roast duck, maybe you want to train a model to detect like roast duck, Peking duck, chicken rice, and all this, right? What you need to do is to create your own custom node. Maybe you can train your own object detector on the different categories that you want to work with, and you can include that as a custom node to run with Peking Duck. Should anonymous attendee ask, should they detect something else instead of duck out of the 80 classes? Well, I guess the picture, it just doesn't look like any other things out of the 80 classes. Like it's not a bus, it's not a car, it's not a ball. So it basically just doesn't detect anything.
I'd like to add in is that earlier in the demonstration by Li-Ping, he specified that it was a duck class, right? So by default, because in the config files, Li-Ping actually specified to look for ducks. If there are no ducks detected, it won't show, right? So that's the reason why it may not have detected the other 79 classes either. Right. So yeah, it's really highly configurable. If you want to detect the whole spectrum of all 80 classes, you can just edit the IDs to list everything from like 0 to 80, right?
Yeah, and just to add to that, so what Sydney was alluding to here was basically the default for detect IDs is 0. So it would, when you run the demo, it would just detect humans. But I changed it to 14, right? So that was able to detect a bird. But you can actually just keep adding more. Like if you make it like 0 and 14 now, and if there's an image of a human walking next to a duck, it will be able to detect both. And you can just keep adding these IDs based on the table that we have. Okay, I think we have answered most of the questions, right?
Li-Ping, there's another question on multi-threading and multiple inputs.
Okay, let's see. Would it be possible to run multiple video streams at the same time? If you want to use multi-threading for the videos and batch the frames for the model, does this have to be coded into the custom node? Okay, so for the first part of your question, right now, PeekingDuck can only handle one video stream at a time. So if you want to work on the case with multiple video streams, you may need to use maybe something like Kubernetes engine and then spin up different kubelets, and each one basically runs a instance of PeekingDuck. So that's something that actually we are going to spend more time looking at it seriously now that we have launched it, and we want to see how we can actually do this. If you want to use multi-threading for the videos and batch the frame for the models, okay, so there is one setting here that I want to show you. So I'm not sure whether we're talking about the same thing, but under the input.live node, right, there is a configuration that you can change that is called threading over here. So by default, it is set to false, but you can actually set it to true, and we find that this will actually increase your FPS up to like 30% if you are using Mac OS or Windows 10. Unfortunately, right now for Linux, we do have some issues with threading. So that's why we set the default to be false. But if you are not using Linux, then you can set this to true, and you should see quite a significant increase in your frame rate. Okay, someone else also asked how to choose model. How do we choose type? Okay. So, oops, let's go to YOLO. Okay, so maybe I will just do a quick demo here to give you a sense of what it's like if you want to change the different types of models. So let's revert back to the original demo, output.screen. And I also want to, in this case, I also want to show you guys, you can actually check out the FPS. So demo.fps node and draw.legend. I hope I remembered them correctly. Okay, let's see if this works. Okay, so right now you can see that this is the basic demo that I showed at the beginning, but the difference here is that I also have this legend at the bottom left, and this is showing the frame rate, and it's running at, let's say, about 9 FPS, 9 to 10 FPS. Okay, so now instead of, the question was how to choose the model type, right? So let's go back to YOLO, and you can see that right now we offer two model types, which are V4 and V4 Tiny. So V4 Tiny is the one that is a lightweight version because the backbone is, I believe, is a mobile net architecture, whereas V4 is the heavier one, but more accurate one. And I think the backbone is some dark net architecture. So the default is V4 Tiny. And I'm going to change it to V4 just to show you how to do it and what is the difference in the frame rate. So this would be model type, and I will change it to what was it, V4. I'm gonna run it again.
Leaving tiny.
This is tiny, is it? This should be correct. I'm running V4 because I want to show the difference in the FPS. David Ong said it would be nice to support detect IDs with a wildcard. Yeah, that's true. If you wanted to detect all 80 IDs, I believe right now you have to write all 80 numbers. So that would be a nice feature to implement and something we can definitely consider. So yeah, okay, so this is running the V4, the heavyweight model now, and you can see that it's a bit laggier. The frame rate is 1.6 compared to just now, which was almost 10. So it's like 5 times, 6 times slower. And that basically, I hope that answers your question on how you can change the model type over here. So it's the same with posenet and any of our other models over here. Okay, asks, is there an equivalent for PeekingDuck for NLP? Not right now, but that is actually quite an astute observation because the way we create our nodes and pipelines, right, it's not limited to CD. Basically, you can create input nodes to read from a certain document or corpus and output a summary. That's entirely possible, but we don't have one yet. Daniel asks, are there any plans to incorporate this pipeline into API endpoints? Yeah, so that's something that we have started to look at, and actually for some of our projects like Genesis Gym, we have incorporated certain custom nodes where we have to call certain Google Cloud endpoints and stuff like that. But we are still looking into this. I'm not sure how much variability there might be. I mean, if we are considering all three major cloud players like Azure, AWS and Go, and then they might all gonna be the node is gonna be quite different. So maybe it's better to create a custom node for that specific use case. But if there is quite a lot of demand for that, we can certainly look into how we can create one for that. Yep. How do you run PeekingDuck in debugging mode? Sydney, Tiwei, Kevin, you guys want to take this one? I think while they are, I think one thing you can try is, like, if you want to find out, like, you try certain nodes and then you get certain errors, right? One thing you could do is maybe you could try in a collab and see if like the outputs that you're getting are exactly what you thought they should be, and this is probably one of the easiest ways to do it. I'm not sure if any T-Way, Sydney or Kevin, you have any other comments about this?
I think the way we, I mean, the principle and the way we approach the design of PeekingDuck is that we want to keep it kind of, we want to let the users be like really hands-off from this CV pipeline part of things most of the times. So we try to provide some information, like some useful logging, such as, you know, whether you are getting the right nodes or getting the right config file configs for your run. And if it fails, you know, we'll try to tell you why. But if you really want to do debugging, perhaps like what Liping mentioned, that there is the Python API which you can use, and you can inspect the data at every single point. So that will be something useful also. So I'm not sure what you're looking for in that particular, if you're looking at for anything in particular, but I think that's the first thing that comes to mind.
I think if you want to try doing something like this, you can reach out to us via the Discord server or the discussion board, and we'll be happy to discuss with you further on this. Okay, someone else asked, is there a way to access the previous frames instead of just the current one? Oh, that's a good question. So let's go back to this, right? So this person has noticed that our pipeline flows sequentially. So at the end of the loop, what happens, right? So I think there is one thing I can think of right away, and that is you can create a custom node. So let's say that if you want to access the previous image frame, you can create a custom node somewhere in between where it takes the IMG from the and basically keeps storing it over time, and maybe you can like pop it over. You can keep 1 or 2 frames over time, and that would allow you to basically sort of like save the previous frames instead of just using the current one. There may be other ways that I can't think of at the moment, but yeah, that seems to be the most straightforward one. Any other questions?
So I guess to answer the question, I think this is also a bit related to the earlier question about batch inference. I think the idea is that, you know, we provide you the few Lego bricks for you to try, a few important Lego bricks for CV inference workloads. But the rest of the use cases is really up to you to give it a shot, right? And you can be creative about it. So like Liping said, to access the previous frame, probably you want to create a custom node to do some kind of accumulation before passing it on to do a double kind of operation, right? And similarly for the batch operation, you know, what you could write is what I could think offhand, right, is you can inherit the input live and just apply this inherited custom node 4 times in your pipeline, right? So that'll be interesting. We've never really tried it before, and maybe we should. You know, that's a good feedback. Right, thanks.
Okay, Lawrence, you raised your hand. Do you want to say something?
Wait, I need to.
No.
Okay.
I commented already. Yeah.
Okay. Okay, I think we have answered all the questions so far. Okay, so I think if there's nothing else, then just want to thank you guys again for coming for this webinar, and yeah, just keep watching this space. Definitely we'll keep adding new nodes and use cases to Peking Duck. So every time we add new stuff, we will probably post on LinkedIn and write a few articles. And if you join our Discord channel or discussion board or follow our GitHub page, then most likely you'll get a sense of what's going to come over the next few months now. So yeah, thanks for coming and see you guys again. Bye. Okay, thanks a lot, James. I think the person who asked the question about Dabble, Kevin, has answered that. Okay, looks like there may be a few more questions still coming in. So I think the developers will stay behind for a bit of time. And then if you guys still have any other questions, we'll try to answer them right now. Okay, it looks like there's no other questions. Okay, guys, I think it's a wrap. Thanks to everyone for coming. See you.